Dear students, good evening. I am Ramdas. I welcome you to my channel Maths from Basics for You. So this is my class number or video number 51 for you. So dear students, in the previous classes you have learnt quite a number of problems on circles. So if I start doing more problems on circles, I will not be doing justice for other chapters. So what I have decided, let me do some, all these days I have done almost all the problems I have done for you are all important problems for the examination point of view. So now I have one more problem which is very important, which I am going to do it for you, and after that let's stop problems on circles momentarily and move on to other chapters. So I am planning to take Leibniz theorem for you, that is once again back to differentiation, because I had left differentiation earlier, so I want to continue with that and parallel to some other chapters also in the benefit of you students. So dear students, before I start, so I would like to request you and advise you that as you are important to me, even all the children and every child in this world are my students. I would like to help them. Every child in this world, I would like to help them in mathematics, and I want them to be good in mathematics. As such, I am doing these videos for them also. So I alone cannot spread this knowledge, because as an individual, I cannot circulate all this myself. So I need your help. I need your cooperation, I need your support in spreading knowledge to other kids. As such, I want you to share, like and subscribe to my channel so that my YouTube reaches every nook and corner of this world and every child is benefited out of my video. As such, please like, share and subscribe, and after subscribing you need to strike the bell button, then select all, so that whatever videos I post, it will reach you wherever you are and wherever I am. So with these words, let's start a problem and go ahead. So we have a problem that is on circles. What happens when two circles touch externally or internally? I am going to write the figure and the problem on the board, and you watch me doing it, and parallelly keep your pad before you, pad, a notebook or rough sheets, whatever you want beside you, and start writing simultaneously along with me. By that you learn. If you just glance it or if you just read it, you will never be good. So I have been telling you, one writing is better than 10 readings. So instead of just going through, brushing up with my video, please along with my video, try to make notes and try to follow it. Please be sure that definitely I am sure you will learn maths very fast. So let's concentrate without wasting our time. Let's do it. So let's start. So dear students, we have a problem here which is important for the examination point of view, because such problems will come in the exams. So here we are given, show that the circles x square plus y square minus 2x plus 6y plus 6 equals to 0 and x square plus y square minus 5x plus 6y plus 15 equals to 0 touch each other. So dear students, I have already drawn the circles, the figure, sketch, and kept ready, because I don't want to waste your time or my time, and moreover, even if you draw a freehand sketch, we will not get a neat sketch like this. So here you find in the figure 1, that is circle 1, we find that bigger circle and smaller circle, they touch each other externally at the point P, right? Whereas in the circle 2, the bigger circle and inner circle, they touch each other at point P internally. Let us see what happens, and we have to prove they touch each other in both the cases. So let's start. So considering the first circle, what I'll do? Considering the circle 1. They touch each other, they touch each other externally, isn't it? They touch each other externally. See this? They touch each other at point P. Now, second, the distance between their centers is the sum of its radii. So radii is a plural, radius is a singular. So the sum of this centers gives the distance between point A and point B. That's what it means. So that is AB equals to AP plus BP, right? What is AP? AP is nothing but the radius of largest circle. So that is R1, and BP is the radius of smaller circle, R2. What will be the AB? This what is now? Now, when they touch externally, their sum is nothing but their sum of their radii, isn't it? Now, we'll consider circle 2. Considering circle 2, they touch each other internally. And their distance between their centers, between their centers is the difference. In this case is a difference, is the difference of its radii. So what happens in this case? I'll rub this. Yes, sir. Rub it, sir. That is here, they touch each other internally. Now, AB equals AP minus BP. AB will be AP minus BP, that gives the center. What is AP? AP is nothing but the radius of larger circle, bigger circle, that is R1 minus R2, where BP is the radius of smaller circle, right? So look at this. So let us consider the equations of two circles and find its center, its radius, right? So what we'll do? I'll rub this. Now considering the equation of the circle 1, that is x square plus y square minus 2x plus 6y plus 6 equals to 0. So what happens here? We'll compare this equation with the general equation to circle, like in the earlier case. So comparing it with general equation. What is that? That is x square plus y square plus 2gx plus 2fy plus c equals to 0. Then this is our general equation of circle. So now you 2g, what is 2g? In this case is minus 2, right? So we'll find the value of now. That is 2g equals to coefficient of x is minus 2. Therefore g will be minus 2 by 2 is minus 1. I'll rub the sketch. So I hope you have understood this. Let me rub this. Circle 1, g equals to minus 1. Now we'll consider 2f. What is the coefficient of f here? Is 6. Therefore f will be 6 by 2, that is 3. F will be 3. And what is the value of c? Is nothing but 6. C equals to 6. Done. I'll rub this. Okay, students. Now what we'll do is we'll find the radius of the circle. Lastly, the radius of circle 1. We know that r equals to square root of g square plus f square minus c, that is nothing but what? Value of g is minus 1 plus 3 square minus 6. I'll rub this. we'll solve this. R equals to 1 square is minus 1 square is 1 plus 9 minus 6. So that is nothing but 1 minus 9 is 10, 10 minus 6 is 4. So that is 4, and this becomes square root of 4 is 2. So therefore R equals to 2. This is pertaining to circle 1, right? R equals to 2. We have got all the values. G equals minus 1, F equals to minus 3, R equals to 2, and C equals to 6. Now we'll go for the next circle. I'll rub this. Considering circle 2, what is that? X square plus y square minus 5x plus 6y plus 15 equals to 0. So we will try to find out its center and its radius. So what we'll do, we'll compare this equation with the general equation to circle. So the general equation is what? X square plus y square plus 2gx plus 2f5 plus c equals to 0. We'll compare that. So accordingly, what happens here? I'll write that comparing it with general equation, that is, I'll write off y square plus 2gx plus 2fy plus c equals to 0. So in this case, 2g is minus 5, equals to minus 5, therefore g equals to minus 5 by 2. So second case, g equals to minus 5 by 2, second circle. 2f equals to 6y, that is 6. Therefore, f equals to 6 by 2 is 3. So, f equals to 3. F equals to 3. C equals to 15. 15. And radius. So, radius r equals to square root of g square plus f square minus c. R equals to square root of g is minus 5 by 2 minus 5 by 2 square plus 3 square minus 15. I'll rub this. So r equals to, this becomes what? Minus 5 by 2 is minus 25 by 4. This becomes 25 by 4 plus 9 minus 15. Right? So what I'll do, you have to take LCM. So I'll take LCM here, that is 25 by 4 plus 9 by 1 minus 15 by 1. 4 is LCM. It goes one time. 1 plus 25 is 1 into 25 is 25 plus 1 goes 4 times. 4 into 9 the 4 9s are 36, and this goes 1 time 4 times 4 into 15 is 60. So this becomes 25 plus 36 is 61. 61 minus 60 by 4 is nothing but 1 by 4. So under the root this is. So what happens to this? This becomes under the root 1 by 4. Right. Therefore radius will be, once it comes out, it becomes half. So R will be half. I rub this to save space. This is nothing but half. Now we have to calculate a center. Center is what? That is minus G comma minus F. Now what I'll do, I'll calculate a center of circle 1. Let's say for circle C1, that is what? Minus G. So what I'll do, I'll use floor bracket because we cannot have to. So I'll write like this. So G is minus G. So we have G minus 1. So I take this minus outside, this minus here, and that is minus 1 comma, and this minus I'll write as this. And what is F? Value of F is 3. So what happens to this? That is center of circle 1. Okay, I'll write like this. Circle 1. It's already here, you will get confused. Circle 1. So circle 1, that is minus into minus plus 1. Minus into 3 is minus 3. Right? Now we will calculate C2, center of second y thing. That is, what is G? Once again, minus 5 by 2 comma minus 3. So minus into minus plus. C2 will be 5 by 2 comma minus 3. Now what you have to find? You have to find AB, because both the case externally as well as internally we have to find the value of AB. In the externally it was AB is what? R1 plus R2. In case of internally, when the circles are touching internally, AB equals to R2 minus 1 R1 or R1 minus R2, isn't it? So in a nutshell we have to find the value of AB. Here what has happened? I have got C1 and C2. Supposing instead of C1 and C2 I call this as A and I call this as B. I call this C1 as CA, C2 as CB. If I have to find the distance between center of A and center of B, can't I use distance formula? Yes. Using the distance formula, you can easily find the value of AB. So now AB equals question mark. Using distance formula, we have what? D equals to, in case distance here in this case is between A and B. Right, so there also A and B. So I'll call this AB and write this properly. Distance formula D equals to AB, which is nothing but x2 minus x1 the whole square plus y2 minus y1 the whole square. Right? Suppose you call this as x1, this as y1, this as x2 and this as y2. I substitute these values here. I rub this. Now AB equals to square root of x2 minus x1, that is 5 by 2 minus 1 the whole square plus y2 is minus 3 minus y1, minus of minus becomes plus 3 the whole square, correct? Here what happens here? We have minus sign and here we have minus 3, isn't it? This minus sign and minus 3, the minus into minus becomes plus. So what happens here? I rub this. I'll solve this. This is 1. 5 by 2 minus 1 by 1. 2 is the LCM. 2 goes one time, 1 into 5 is 5, minus 1 2 the 2, that is 3 by 2 plus 3 by 2. This is 3 by 2 the whole square minus 3 plus 3. It becomes 0, done, plus 0, that is nothing but square root of 9 by 4, isn't it? I could easily cancel this root, and other ways you can cancel this 2 and cancel this root. But anyway, there are some students who may not follow that if I go for shortcut method. So for their benefit I am going to go the other way. So what happens? What is this? This is nothing but AB equals what? Square root of this becomes 3 by 2. AB equals to 3 by 2. But AB equals what? R1 minus R2, isn't it? Or R2 minus R1, both are same. So, or R2 minus R1, right? So what I'll do? What is R2? R2 is 2 and R1 is half. So that is nothing but 2 minus half, that is 1 and a half. 1 and a half is nothing but 3 by 2. Therefore, AB equals to 3 by 2. See, here also you got A by 2, AB equals 3 by 2, here also AB equals 3 by 2. Done. So this I'll show you otherwise, that is 2 is LCM, 1 goes 2 times, 2 into 2 is 4, this goes 1, that is 3 by 2. Done. Both the case it is 2 minus half is 1 and half, 1 and half is nothing but 3 by 2, shortcut method. So what is R1 minus R2? R1 minus R2 is nothing but they touch internally, isn't it? Therefore, the circles, that is, therefore, the circles touch internally. Done. So we have proved. I love this. Now, in both the cases, earlier case also, P was the point of contact, whether it was externally or whether it was internally. So let's find the point of contact. Lastly, to find the point of contact. Contact P. So to find the point of contact, we'll draw this radius, that is R1 plus R2. So here I call this A, that is minus G minus F, and this is B minus G minus F, where we are going to draw the circle, and this is our point P, right, when they are touching externally or internally, whatever it is, right. So now what we'll do, what about A circle 1? So what happens to this? A will become minus G, because minus of minus becomes plus 1, and this 3 becomes minus 3, isn't it? Minus F, that becomes minus 3. And what about B? That is minus will become plus 5 by 2 comma minus 3. Got it? So what is this? Minus sign is there. That is minus 1. Minus into minus plus, we got plus. And F, this is our G. What is F? Minus F. So F is 3 minus F, so 3. That becomes plus 1 minus 3, right? Likewise here also, minus G comma minus F, so this is minus, and this is minus 5 by 2 comma minus F, F is 3. So minus into minus becomes plus 5 by 2 and then minus 3. That's what it is. How you got this way? So their radius for AB is what? Radius is, this is 2 and this is half, R2 and R1, right? Our AB was 2 and BP was half. So 2 comma half. That's what it means. Note here P divides AB externally in the ratio AP by BP. So AP is nothing but our, in the figure we had done this, right? This is our A, this is P, and this is B. So the ratio of AP by BP. What is AP? AP is 2. What is BP? BP is half. We have got some, let's see, half. I rub this. So BP is half. So that becomes what? Denominator will go to numerator and get multiplied with 2. That becomes 4 by 1. Hence, the ratio of AP by BP is 4 by 1. Therefore, AP by BP equals to 4 by 1. I'll rub this. Therefore, the point of contact P equals 4 into 5 by 2 minus 1 into 1 by 4 minus 1, comma 4 into minus 3 minus 1 into minus 3 by 4 minus 1. Let's solve this. So this 4 is nothing but the ratio AP by BP, and 1 I have taken this point, 1 into 1. So let's solve this. P equals to this 2 and this 2 cancels. 2 5s are 10 minus 1 by 3, comma 4 3s are minus 12, minus into minus plus 3 divided by 3. Ten minus 1 is 9 by 3, comma minus 12 plus 3 is minus 9, minus 9 by 3. So that is nothing but 3 cancels here. Therefore, P equals to 3 1s are 3 3s are 3 comma this one, 3 1s are minus 3 times. This is minus 3. Therefore, the point of contact P equals to 3 comma minus 3. Therefore, the point of contact P equals to 3 comma minus 3. This is the required answer. So dear students, I have done this problem. So it's a very interesting problem, very tricky, and if at all you expect a problem for examination, this is the one, because this problem has everything. So here you have to be sharp, quite alert, because you may go wrong here. You have to do this problem once again, try to practice it Practice in the sense how? Not don't run through the problem. What you do is, as I have said earlier, keep a notebook beside you and try to work out this problem along with my YouTube. So try to practice this. If you do it once or twice, enough, you'll remember it. So I had told you, one writing is better than 10 readings. So mathematics is one subject where you cannot by heart or you cannot read. You have to practice using a pen and book. So practice it again and again, you'll get it. Very simple problem. Only thing, you have to be alert while doing this problem. Once you understand this problem, the concept of it, very simple. There is nothing difficult in this. You have to use a distance formula. Remaining is quite similar to what we have done earlier, to find a center, to find a radius, and to know the constant. After that, we have to find a distance formula, and we have to find a ratio, how they divide each other. Once you know that, use this formula and substitute the values, it's over. So dear students, after doing this, there are a lot of problems. If I wish I can do it, but time constraint, so I don't want to waste your time and my time. So if at all you require more problems, let us see later. So I put an end to circles, and let us think about doing some other topic, because if you go on doing problems, at some point of time you will get fed up. The moment it says circles, what is this, sir? Every time circles. The moment I open your YouTube, I find only circles. This I want to make you strong in circles, so that whatever problem is given to you in the examination, you should be in a position to tackle it, answer it. So don't learn any subject, whether it is maths, science or any other subjects, for the sake of passing the examination. Learn the subject well to know the subject, not for other things. Once you know the subject right from the grassroots level and understand the concept, maths will be easy for you and you can start scoring full on full. That's the technique behind your way of learning, right? As a student, I did that. I used to take my book out of the class. I used to come home, get refreshed. I used to start my studies on 6:30, start till 1 o'clock, 2 o'clock. Sometimes examination time up to 2 o'clock I studied. And particularly on the day of examination eve, I have studied throughout the night. And morning from 9 to 12 was my exam. I went straight away, wrote my exam when I was in Polytechnic. I wrote the exam without sleeping, and afterwards I came, slept for a while, and again I practiced that for the next subject the next evening. That is the same evening. So you should have the inclination and be hunger to learn the subject well. With these few words, I put an end here and put an end to circles too. With the view and with the promise, we will meet very shortly, and I'll come out with a new topic. I don't know what I'll be teaching you. Most probably I'll go to my differentiation, because differentiation is pending. So I have to plan for Leibniz theorem. I'll take up Leibniz theorem in the next topic. I'll try to teach you Leibniz theorem. So later on we shall see what can be done. So there are a lot to be done. I have to do matrices, limits, infinite series, and so many things. Let us see. One by one we'll do it. So with these few words, I end my video here with the note. We'll meet very soon. Until then, good night. Take care. God bless you. Love you all. God bless you.